Okay, here's my code for lab 6. This program will use an ultrasonic sensor to detect objects and control the robot's movement. The program will start once the button A is pressed, and a 2-second delay will follow. The 2-second delay must be signaled by turning on the green LED light on the board for 2 seconds, then turning it off. The robot must travel a total of 120 centimeters in distance. The robot must continue to drive straight until the obstacle is 80 centimeters away, then stop. Once it reaches the 80 centimeter marker, it will divide the remaining distance in half and use the new distance to travel closer to the object. The robot will repeat this process until it is approximately 5 centimeters away, then stop forever. At the end of the program, the robot will turn on the red LED light on forever. Included the Romy library. Here are the classes. These are the defined constants, trig pen to pen 11, echo pen to 2, centimeter value, wheel diameter value, wheel base, count per rev, left motor speed, right motor speed, stop motor, and T second for a 2-second delay. Here we have the count left variable to store the left encoder count, the count right to store the right encoder counts, and the number of pulses variable to store the number of pulses needed to travel the distance. And my setup function pretty much declares, see the trig pin as an output, echo pin as an input, have the wait for button A function to start the program. Once it starts the program, it'll signal the green LED light to turn on for 2 seconds and turn off. In my void loop, I have disk to store the distance measured from the sensor. From there, I'll have an if statement. If the distance is less than or equal to 80 and the distance is greater than 5, it'll call the drive straight function, and it will stop. Else if the distance is less than or equal to 5 and greater than or equal to 1, the motor will stop. The red LED light will be activated, and it will wait for button A to be pressed to restart the program again. And after that, the red LED light will be turned off. Else, if there's anything else, such as the distance is greater than 80, the drive straight function will be called. And after the robot travels, the robot will stop. For the drive straight function, it has both left motor speed, right motor speed, and the distance. There's a 5 millisecond delay. Oh. Here it resets both encoders to 0. Num pulse, it calls the count for distance function to compute the number of pulses needed to travel the distance. After that line, we set the motor speed to the defined motor speed for left and right motors above. After that, we have a while loop to loop until the pulse count is met. Count left and count right are stored with the encoder counts. If statement, if the left count is greater than the right count, motor speed will be adjusted. Else if count left is greater than count right, motor speed will be adjusted. When it jumps out of the while loop, it'll jump back to its remaining set speed. For the count for distance, this function is used to determine the number of posts needed to travel the distance. The first line here for the variable temp, we're computing the wheel rev per pulse. Once we get that information, we will calculate the number of pulses to travel a certain distance, and after that we will return that temp variable. This is the get distance function. This function will measure the distance using the ultrasonic sensor. Here we declare the variables echo time, disk calc. Echo time is a variable to store the time that it takes off to bounce off an object. Distance calc is a variable to store the distance calculated for echo time. Distance sense is my array that I created to store the measured distance. Array size is just an integer variable to declare that the array size is 8. So for here, I set up a for loop to measure the distance in an array. It will trigger on the sensors to measure the distance. Once it calculates the distance, we will have if statements to determine if the measured distance is valid. So for here, I used the range, the max and min of this sensor found on the data sheet. And then if the measured distance is within spec, it will store the measured distance in our array. And this next for loop is to sort the array elements in ascending order. And so this for loop is to cycle through the array, and the second for loop is to compare values. And an if statement here is placed here to compare values and ensure they are placed in ascending order. And once this is done and complete, we will return the medium distance measured. And that's it. That's the end of my code. We will upload this to my robot. Okay, done uploading. So here is my testing site, marked off the LiFi marker, 10 centimeter marker, 20 centimeter marker, 40 centimeter marker, 80 centimeter marker, and here's the 120. Go. So it's at 80. So it's at 40. So it's at 20. 10. Approximately 5.